Hi everyone. So today we are going to study clipper circuits, and it is one of the easiest topic of diode circuit, or you can say easiest topic of analog electronics as well. Okay. So what do you mean by clipper circuit? As the name suggests, it will clip off a certain part of input signal, but without distorting the remaining part of the signal. Okay. So it will only cut a certain part of the signal. It will not do anything with the rest of the part of the signal. Okay. Let's understand this with the example. So where it is used, actually multiple application can be there. This clipper circuit can be used in multiple application as per the requirement, but one basic use is to remove the noise from a signal. Okay, so let's assume this signal is given and there is this noise present. So now you want to remove this noise. So what you will do, you will use a clipper circuit. How it will remove the noise? It will just clip off this part of the signal, this much part, and from here as well it will clip off this much part of the signal. Okay, it will not do anything with this part. It will not do anything. Okay, so this much part of will be clipped off. So how will your final output look like? Your final output will look something like this. Okay, well and good. Upper part is clipped off, so final output is looking something like this. Okay, so this is simple clipper circuit. Now how we can frame the clipper circuit using diode, resistor, or any other component, that we will see. Okay, so first let's see the classification of clipper circuit. Now this classification is not important at all. This is not important at all. No one will ask you what is a positive biased series clipper circuit. No one will ask you that thing. They can simply ask you what is a series clipper circuit, that you should know, and what is a shunt clipper circuit. So these things they can ask you. What do you mean by series clipper circuit? That means your output and diode will be in series. Will be in series. And what do you mean by shunt clipper circuit? Output and diode will be in parallel. That's it. So you don't need to mug up this classification, that series, shunt, positive, negative, biased. By this you don't need to mug up. This is just to make the understanding easier. Okay, we will see all this type one by one. You just need to understand the analysis, not the name, because in the exam circuit will come, the name will not come. That assume a positive series clipper circuit is there. This will not come. The circuit will come and you have to draw the output waveform. So analysis is important. Okay. So output and diode will be in parallel. Well and good. Let's understand the first circuit, that is positive series clipper circuit. So why it is called positive, that we will see later on. First do the analysis. Okay. So the diode is given, input signal is there, output you need to calculate. So this is the diode. So I hope you guys are comfortable with diode circuit analysis. You have studied open circuit test, you have studied short circuit test. So all these things we have studied, right? This point is V in, this point is. Tell me one thing. If V in is greater than 0, what will happen? If V in is greater than 0, apply the open circuit test. This is your N side, this is your P side. This side is greater than 0, that means this side is positive. And this side, here it is open circuited, so there will be 0 current through the resistor, so 0 will come here. This is grounded, so 0 volt will come here, because we are applying open circuit test, right? So the 0 volt will come here. Now N side is positive, P side is 0 volt. So what will happen? Diode will be off. And if diode is off, what will happen? Your V0 will go to 0 volt. Why it will go to 0 volt? This is the condition, right? Diode is off. This is V0, this is V in. So if diode is off, there will be no current through the resistor, so 0 volt will come here, so V0 will be 0 volt. Second thing, when V in is less than 0, when V in is less than 0, okay, this is N, this is P, this is 0 volt and this is negative. So P side is at more positive. This is 0, this is, let's assume, -1, -2. So P side is at more positive. So diode will be on. And diode is ideal, and if the diode is on, what will happen? V0 will be equals to V in. Because what is happening? This is V in, diode is on, that means it will be shorted. This is the resistance R. This is V in. So V0 is equals to V in here. Well and good. Now you have to draw voltage transfer characteristics. Okay, this term, voltage transfer characteristics. So you should understand what do you mean by this term. Voltage transfer characteristics, VTC. So voltage transfer characteristics mean the plot between output voltage and input voltage. The plot between output voltage and input voltage. So when Vin is greater than 0, your output is 0 volt. When Vin is less than 0, your output is equals to Vin. So the plot between output and input voltage. So that's what we mean by voltage transfer characteristics. Well and good? Okay. This is your V0, your Vin. So when Vin is greater than 0, that means this part. Vin less than 0, that means this part. So Vin greater than 0, that means we are talking about this part only. Okay. So the output is 0 volt. For Vin greater than 0, the output is 0 volt. So output will be 0 volt. And for Vin less than 0, output is equals to Vin. So how will the graph look like? What is the graph of V0 versus Vin? Sorry, what is the graph of V0 versus Vin? What is the graph of V0 equals to Vi? What is the graph of V0 equals to Vi? This will be the graph. But we need to calculate for Vin less than 0. Vin less than 0. This is the part of Vin less than 0. Right? So it will simply be a straight line. Well and good. So this is V0 versus V0 equals to Vin, and the slope being 1. Okay. So you have understood the graph. Let's understand this with the sinusoid waveform. So let's assume your input is sinusoid. So how will your output look like? So when Vin is greater than 0, when Vin is greater than 0, your output was 0 volt. So here your Vin is greater than 0. Here your Vin is greater than 0. So for all this time your output will be 0 volt, right? For all this time your output will be 0 volt. 0 volt. Output will be 0 volt. And for Vin less than 0, your output will be equals to Vin only. For Vin less than 0 volt, your output will be equals to Vin only. So the same waveform will come. The same waveform will come. The same waveform will come. We can assume this to be plus 5 and this to be minus 5 volt. So this point will be minus 5 volt only. And this point will also be minus 5 volt only. Now the question comes, why it was called positive clipper? Why it was called positive? Why this word positive? Because here positive part is clipped off. Here the positive part of input is clipped off. Only the negative part is coming in the output. So why it is called positive clipper? Positive clipper. That means positive part of input signal is clipped off in the output. We can say in the output. So in the output only negative part is coming. So that's it. That's the simple analysis. I hope you all understood it. Okay, let's move on to the next circuit. This is the same circuit, but the diode is not ideal this time. The diode is having some cut-in voltage. So I have told you one simple method how to solve the diode circuit with having cut-in voltage. What you do? If you remember, if the diode is having cut-in voltage, what you do? You take the battery out of it. You take the battery out of it and solve the problem. So what you need to do, you need to draw the voltage transfer characteristic in this one. The same thing you need to do. Whatever we did previously, the same thing we will do here. Okay. So I will just write draw VTC. Draw voltage transfer characteristics. Okay. Now cut-in voltage is given. Since the cut-in voltage is given, what we will do? We will take the battery out of the diode. If we take the battery out of the diode, it will become a ideal diode. This will become a ideal diode. I am taking the battery out of the diode, it will become an ideal diode. This point is V naught, this point is V. How I am taking the battery? This side is N, this side is P. So first negative will come, then positive will come in the same direction. Just I am pulling out a battery out of it. So N will be negative and this P will be positive. Okay, well and good. Now you can apply open circuit test. Okay, open circuit test we can apply. So this point is V in, and if I am applying open circuit test, that means there will be zero current through this resistor, right? So this point will be 0 volt. So this point will be minus 0.7. Are you getting my point? This point will be minus 0.7. This point will be 0.7 volt, and since there is no current flowing through this resistor, so this point will be 0 volt. So this is 0. This point will be minus 0.7. Well and good. So first point we will take when V in is greater than minus 0.7 volt. That means this potential is larger. This potential is larger. N side is larger. P side is lower. When you take the battery out of the diode, you don't need to think anything much. You just need to think which potential is greater. So N side is greater. That means diode will be off. That's it. And if you don't take battery, you need to think sometimes. You need to take examples. Okay, what if it is 0.8? So that's why it is easier method to take the battery out of it. Okay, so I always take the battery out of it, battery out of the diode whenever there are cut-in voltage is given. Okay, so problem becomes easier. So V in is greater than 0.7 volt. That means diode will be off. And if diode is off, that means if diode is off, no current will be flowing through this resistor. So V naught will be equals to 0 volt. Okay, let's take the second case. Here only I can take the second case. And V in is less than minus 0.7 volt. That means N side is lower and P side is larger. That means diode will be on. Diode will be on. That means this will be replaced with the diode will be on. That means this will be shorted. This is V in. This is 0.7 volt and this is your V out. V in diode is shorted because diode is on and this 0.7 voltage battery is there and this will be your V out. So V out will be V in plus 0.7 volt. Well and good. 0 volt and 7 volt. Okay, let's draw the transfer characteristics now. We are drawing the transfer characteristics V naught versus V in. So what is your threshold point? What do I mean by threshold point here? Threshold point means this point where everything is happening. For greater than this value, diode will be off. For less than this value, diode will be on. So the point where every transition is happening, I am calling that threshold point as of now. We will understand the definition of threshold point when we study BJT and MOSFET amplifiers. Sorry, MOSFET biasing. There we will study the meaning of threshold point. But for now, I am calling this point as threshold point. So here my threshold point is minus 0.7. Okay, so for value greater than this, for value greater than minus 0.7 volt, that means these values. For these values, your V naught is 0 volt. So for these values, your V naught is 0 volt. There it is 0 volt. And for less than all these values, your V naught is V in plus 0.7 volt. V in plus 0.7. The slope is positive. Okay, so how will the graph go? The graph will go something like this. Well and good. So this slope will be 1. Slope will be 1. I hope you know how to draw the graph, right? Y equals to mx plus c. Y equals to mx plus c. If the m is positive, the slope is positive, and c is the point where it cuts on y-axis. If it is 3, that means it will cut on 3 at y-axis. So graph will go something like this. So it will cut on 0.7. So it will, if you increase this, it will cut on 0.7. But we are not going to make it, because after 0.7, V out is 0 volt. So I hope you know how to draw the graph. So V naught is equals to V in plus 0.7. V in plus 0.7 volt. Well and good. Understood? Let's draw the output for a sinusoid input. So let's assume this point is plus 5 and this point is minus 5. Now where everything is happening, that is minus 0.7 volt. So I have drawn this minus 0.7 volt here. This is my minus 0.7. So for every value greater than minus 0.7, for every value greater than minus 0.7, your V naught is 0 volt. Okay. So for all these values, here your V in is greater than minus 0.7. So for all these values, your output will be 0. Right? So for all these values, your output will be 0. 0. 0. Well and good. Then for V in less than minus 0.7, your output will be V in plus 0.7. Okay. Your output is V in plus 0.7. So tell me, when your V in is minus 0.7, what will be the value of output? When V in is minus 0.7, minus 0.7 plus 0.7 will be equals to 0 volt. So when V in is minus 0.7, your output will be 0 volt. When V in is minus 5, what will be your output? That will be minus 4.3. So from 0 you will start and you will go up to minus 4.3. From 0 you will start, you will go up to minus 4.3. So nothing is happening with the shape of the signal. The shape of the signal was sinusoid. Currently it's sinusoid as well. The shape of the signal was sinusoid only, and still it is sinusoid only. Are you getting my point? So nothing is happening with the shape of the signal, right? But just this point become minus 4.3 volt. And the positive part and the part till here, it is clipped off. And this will be minus 4.3 volt. Are you understanding the complete analysis? I hope you are understanding the complete analysis. Let's move on to the next circuit and you will be solving that on your own. So this is a negative series clipper circuit. So what do you think what will happen? The negative part will be clipped off. Okay. So let's draw it very quickly, because this is very easy for us now. This is V in, this is your V out. So we will apply open circuit test. Okay. So first thing, tell me, if V in is greater than 0, if V in greater than 0, that means what will happen? Diode will be on. And if diode is on, that means your V naught will be equals to V in. Second thing, if V in is less than 0, what will happen? This diode will be off. And if the diode is off, your V naught will be equals to 0 volt. Well and good. So we can draw the transfer characteristics now. So when V in is less than 0, your V naught is 0. V in is less than 0, your V naught is 0. After that, V naught equals to V in. So how will the graph go? Slope is positive, so the graph will go something like this. This is V naught equals to V in. Okay, this is the transfer characteristics. Now you can draw for sinusoid as well. So only for greater than 0, V naught equals to V in. For less than 0, output will be 0. So for all these values, your output will be 0. For all these values, your output is 0. Only for these values, it will be there. V naught is equals to V in. तो आई होप सब कुछ समझ में आ रहा है आपको, बड़ा आसानी से सब कुछ अपने समझ पा रहे हैं. एंड बी इट हिंदी यूजर और इंग्लिश यूजर, एवरीवन इज able to understand all the concept that I am teaching. Okay, so if you like the content, you can comment down or you can message me on Telegram that you liked it. Okay, yeah. So let's move on to the next circuit. Now the same circuit is there, but there is some cut-in voltage. So what you will do? You will take the battery out of the diode. Okay, so what you need to draw here? You need to draw the voltage transfer characteristics. Okay, just take the battery out of the diode. this will be your V naught, this is your V in, this is 0.7 volt, and this is the diode. So first we will apply open circuit test, right? So if open circuit test we apply, okay, applying open circuit test. So if we apply open circuit test, so this resistance will have 0 voltage drop, so this will be 0 volt, and this is 0.7, and this is V in. Okay, so if this point is 0, this point will be 0.7 volt. Well and good. So first thing, if V in is greater than 0.7 volt, if V in is greater than 0.7 volt, that means diode will be on. Diode will be on. Okay, and if diode is on, what will be your output voltage? Tell me. Output voltage will be V in minus 0.7 volt. Are you able to write it without even drawing the circuit? You should be able to write it without even drawing the circuit. Diode is on. Okay, diode is on. This will be our battery, and this will be your V naught, and this is your V in. V in minus 0.7. Are you getting my point? V in minus 0.7 is equals to V naught. V naught is V in minus 0.7. The second thing, V in less than 0.7. If V in is less than 0.7, that means P is at lower side and N is at higher side. That means your diode will be off. So if diode is off, V naught is equals to 0 volt. Very easy, well and good. Just open circuit, then see P is at higher potential, that means diode is on. P is at lower potential, that means diode will be off. Now you have to draw the transfer characteristics. So first we will mark our threshold point. Actually, ideally it shouldn't be called threshold point, but for ease of understanding, we are calling this a threshold point. Okay, so there is no term for this point. Actually, there is no term. You threshold point or anything, no one will tell you any term for this point, like this point. It is just the point where all the transition is happening. So we can call it threshold point or transition point. Better I should call transition point. Okay, I will call it transition point now. So what is my transition point? Transition point is 0.7 volt. Oh, sorry, 0.7 volt will come that side. So here 0.7 volt will come. So this is my transition point. So before V in less than 0, diode is off. That means V naught is equals to 0 volt. V naught is equals to 0 volt. After V in 0.7 volt, your slope is 1. Slope is 1. So this is how the graph will go. At 0.7 you are having 0 volt, at 0.8 you will have 0.1 volt, at 0.9 you will have 0.2 volt, at 1 volt you will have 0.3 volt, right? So this is your V naught equals to V in minus 0.7 and this slope being 1. Well and good. Let's move on to the next circuit. Or before moving on to the next circuit, you have to draw it for a sinusoid. So let's assume this point is plus 5 and this point is minus 5. And this point is, what is our transition point? Transition point is 0.7. This point is 0.7 volt. So everything below 0.7, when V in is less than 0.7, your V naught is 0 volt. So everything below 0.7, everything will be 0 volt only. When V in is less than 0.7, it will be 0. So all these points will be gone to 0, right? All these points will go to 0. Now let's check for V in greater than 0.7. So your output will be V in minus 0.7. So at 0.7, what you will be having? At 0.7, your output will be 0 volt. And at 5 volt, it will be 5 minus 0.7. So at 5, it will be 4.3. Well and good. So from 0 to 4.3, you have to increase. 0 to 4.3 like this. At 0.7, you are having 0 volt. At 5 volt, you are having 4.3 volt. So from 0 to 4.3, like this it will go. 4.3 volt, 4.3 volt, like this. This will be the waveform, right? Let's move on to the next circuit. Now we are studying negative series clipper circuit but with the positive bias. All this circuit previously we studied that was unbiased. Here I have written, I guess, unbiased. That means there was no voltage there. There was no battery. Only input voltage and output voltage was there. Only input that we have applied was the voltage. It can be sinusoid, it can be anything. But here a positive bias will be there. Here this voltage will be there. So this is the different thing now. Okay. So now we have to analyze the circuit. I hope you will be able to do it on your own as well. So let's see. So this is our diode. This is V in, this is V naught, and this is the diode, which is ideal. Okay. Okay, tell me one thing now. How will you apply open circuit test? Apply open circuit test. When you apply open circuit test, what will happen? This will be V in only. This point will be V in only. But this point will be what? VB, right? There will be no current through this resistor. So this point is 0, this point is VB. So VB will go here. Are you getting my point? I am applying open circuit test. That means no current through the resistor. So 0, this is 0, then VB, then this point will be VB here. Right? 0, VB, and this point will be VB. Okay. So now what will happen? First thing, when Vin is greater than VB, that means your diode will be on. Diode on. So if diode is on, what will be the circuit? The circuit will look something like this. This is your V naught and this is your V in. So complete V in is simply occurring across output. So complete V in is going towards the output. So V naught is equals to V in. Well and good. And when V in is less than VB, when V in is less than VB, what will happen? The diode is off. And if the diode is off, what will be the circuit? I think I should draw it here. When V in is less than VB, diode will be off. So what do you think, what will be the output? Tell me. If you say 0, your network analysis is very weak. Okay, you shouldn't say 0. Output will be VB. Why it is so? Don't be demotivated if I say things like that. It's just to motivate you so that you study harder. This is V in and this is V naught. And this is VB. So diode is off. That means diode is open circuited. So if this point is 0, this point will be VB because there is no current through this resistor R, right? So V naught will be equals to VB. Are you getting my point? No current through this resistor R, so complete VB will go to V naught only, right? So we are drawing the voltage transfer characteristics. So what is the point where everything is happening? That point is VB. For us, that point is VB. Transition point is VB. This is our transition point. Okay. So for V in less than VB, your output is VB volt. VB can be anything, it might be 2, 3, anything. Okay. I should have written here one thing, that VB is positive. We should consider this as positive. Okay. So for V in less than VB, your output is VB only. Output is VB only. Yeah. Till this point, it is VB only. And after that, V naught is equals to V in. So slope will be 1 and slope is positive. So the graph will go like this. V naught is equals to V in. The slope is 1. You can check here, V naught equals to VB. That means at V in equals to VB, what should be the voltage? At V in equals to VB, the voltage should be VB only. At V in equals to VB plus 1, what should be the voltage? It should be VB plus 1 only, right? So it is VB plus 1 only. Because V in is equals to VB. So this is simple maths that we draw the graph. Well and good. Okay. Let's draw it on a circuit. So what was the point where everything was happening? That was VB. So this point is VB. For everything less than VB, so I should have made for everything less than VB, everything less than VB, this point, this point, this point. In exam, you will be able to tick the correct answer very quickly. But here, I have to make you understand. That's why it is taking time. Once you understand the analysis, it will be all easy for you. So for everything less than VB, your output is VB. For all these points, your output will be VB only. Well and good. And let's assume this point is 5 and this point is minus 5. So, but there is no use of that, because for V in greater than VB, your output is equals to V in only. V naught is equals to V in only. So the exact same graph will come. Exact same. Okay. So exact same graph will come. Making sinusoid is very difficult on writing pad. Seriously. Just bear with it. Okay. This is pure sinusoid. You just have to look it like that. This is sinusoid only. So just erase it. Are you getting my point? This point will be 5 volt only. So it is still negative clipper only, because negative part is clipped off, but we have given a positive bias to the positive bias. Okay, the negative part is clipped off, but it is clipped off from a positive bias from here, from VB. Well and good. Okay, this is VB. Let's move on to this. This is simple question given to you. This is a problem. You have to draw the voltage transfer characteristics. So can you do it on your own? Try doing it on your own. Okay, first try doing it on your own, then only see the solution. आपको कसम है गेट एग्जाम की, पहले खुद करना है, ठीक है, सॉल्यूशन डायरेक्ट नहीं देखना है. Don't see the solution directly. Okay, so do it on your own. So let's see the solution now. I will put this somewhat upward. Okay, yeah. So cut-in voltage is given. That means I will take the battery out of the diode. Then I will apply the open circuit test. Okay, so directly I am writing open circuit test. So tell me, this point will be V in. I am applying open circuit test. Tell me the potential of this point. This point. Tell me the potential of this point. I want to know the potential of this point. I am taking the battery out of the diode. That will be 0.7 volt. Here I am having a resistance, and here I am having a battery of 1 volt. And this is grounded. This is resistance R. So what will be the potential of this point? That will be 1.7 volt. Okay. So our transition point is 1.7 volt. So when V in is greater than 1.7 volt, that means your diode will be on. Diode on. Now if the diode is on, tell me what will be the output voltage. You should be able to tell now. If diode is on, what will be the output voltage? This will be shorted. So simply output voltage will be, this is our output, right? If this is shorted, simply output voltage will be V in minus 0.7, right? So output voltage will be V in minus 0.7 volt. Well and good. And for V in less than 1.7 volt, what will happen? The diode will be off. Diode will be off. So this diode will be off. So if diode is off, that means what will be the output voltage? Tell me. It is 0.7 minus 0.7, 1 volt minus 1 volt. What is the output voltage if diode is off? So if diode is off, your output voltage will be, simply this will have no current. So this 1 volt will go here. So output voltage will be 1 volt. Output voltage will be 1 volt. Okay. So V in the point is 1.7 volt. So for less than 1.7 volt, it is 1 volt. For less than 1.7 volt, it is 1 volt only. It is 1 volt. And for greater than 1.7 volt, it will be slope is positive, slope is 1 and positive. So it will go like this. You don't need to see where it will cut on y-axis. You just need to see the slope is positive. So the graph will go like this. That's it. Then you can recheck. What you can recheck at 1.7 volt, what do you expect? If you put V naught equals to V in minus 1. V naught equals to V in minus 0.7. So at V in equals to 1.7 volt, what do you expect? 1 volt. Are you getting that point? Yeah. So this point and this point should be the same. So this is how you can check. At V in equals to 1.7 volt, I should get 1 volt here, and that I am getting. So graph will be simply go like this. The slope is positive, so the graph will go like this. If the slope was negative, the graph will go like this. That's it. Okay. So a lot of students face problem in making the graph, I know. So, but that's how we can check. The slope is positive, that's it. And from where we should start? 1.7, 1 volt. So from 1 volt we are starting. Positive, then we will go like this. Negative, then we will go like this. No need to see here. Okay. So this was a very easy problem. Let's move on to the next circuit, that is negative clipper circuit, but a negative bias is there, and the series I forgot to write. Okay. So this is negative series clipper circuit and a negative bias is there. So again, do it on your own. You don't need to see the solution. The diode is ideal this time. So what we will do? We will apply open circuit test. So tell me directly, or we shouldn't do it directly. Just apply open circuit test. So this point will be minus VB and this point will be V in, right? If this is 0, this point will be minus VB. There will be no current through the resistor. So this point will be minus VB. Well and good. So first thing, when V in is greater than minus VB, if V in is greater than minus VB, your diode will be on. And if diode is on, what will be the output voltage? The complete V in will come across the output. So your output will be V naught will be equals to V in. And V in is less than minus VB. That means diode will be off. The diode will be off. That means your V naught will be equals to, tell me what will be your V naught? There will be no current through the resistor because diode is off. So V naught will simply be equals to minus VB. Well and good. So V naught versus V in. Okay, so what is the transition point? That is minus VB. This point is transition point. So for V in less than VB, it is minus VB. Minus VB. For V in less than minus VB, it is minus VB. So this point is minus VB. And for V in greater than minus VB, V naught is equals to V in. V naught is equals to V in. So from where we are starting? At V in equals to minus VB, or output voltage is minus VB only. And then the slope is positive. So V will go like this. At V in equals to 0 volt, or output should be 0. So V in equals to 0 volt, output should be 0. V in equals to 1 volt, output should be 1. V in equals to 2 volt, output should be 1. So this is how it will go. This is V naught is equals to V in. Are you getting my point? Okay, well and good. So this is the transfer characteristic we have drawn, and now we can draw it on the sinusoid. So what is our point? That is minus VB. Transition point is minus VB. So we can draw it on our sinusoid. So this point will be minus VB. Okay, so this point is minus VB. So everything above minus VB, your V naught is equals to V. So everything above minus VB. So I should take this graph a little more down. So everything above minus VB, that means this much graph. that would be equals to V in only. So the same graph will come. And for V in less than minus VB, for V in less than minus VB, diode will be off. So your output will be equals to minus VB only. If you are just seeing the circuit and you are not doing anything in your rough notebook, you will not understand anything. Okay, just watching the circuit and doing nothing in your rough notebook will not get you anything. So you should be writing along with me in your rough notebook at least, because I am providing the fair notes. If you are making the fair notes by your own, then it's very good. But if you are writing in your rough notebook, then also you will understand a lot of new things. So you should be writing along with me. Okay. So for V in less than minus VB, your output is minus VB only. So for all these values, your output will go to minus VB. All these values, your output will go to minus VB. And then now I will pause the video and make the sinusoid. Okay, because it will take time for me to make the sinusoid. I guess I can, yeah, I can make the sinusoid by my own. So yeah, okay, done. Okay, so V naught is equals to V in, and here V naught is equals to minus VB. This point is minus VB. Well and good. Okay, let's move on to the next circuit. So again, you have to draw the transfer characteristics. This also you will do on your own. Why do I again and again say you should do it on your own? Because this will help you to build problem solving skills. If you just watch the solution and do nothing in your pen and paper, you will think that I am teaching very good, and you will think that you are understanding everything. But in actual, you are not understanding anything if you are not doing by your own. So that's why try to do it on your own, whether it is right, whether it is wrong, whether it takes you 1 hour, 30 minutes, 15 minutes, or 2 minutes, but you should do it on your own first. Then only your problem solving skill will develop. Okay? So what we will do, we will apply open circuit test. Okay, but we need to take the battery out of it, because this cut-in voltage is given. So this will be our diode, which will be open circuited, and we are taking the battery out of it. This is our V naught. This is 0.7 volt. This is resistor R. This point is minus 1 volt. Tell me what will be the potential of this point. Tell me quickly. Sorry, minus 1 I shouldn't write. I should write 1 volt only. So tell me what will be the potential of this point. And this point is V in. This point is V in. What will be the potential of this point? Minus 1 plus 0.7. This point is minus 1. This is plus 0.7. That means this point will be minus 0.3 volt. And this is V in. Okay, this is V in. So what is the first thing that comes when V in is greater than minus 0.3 volt? When V in is greater than minus 0.3 volt, that means diode will be on. And if diode is on, that means your V naught will be equals to V in minus 0.7. And the second one, when V in is less than minus 0.3 volt. When V in is less than minus 0.3 volt, your diode will be off, and your V naught will be equals to minus 1 volt. This is V naught, this is V in. What is our transition point? That is minus 0.3 volt. Is minus 0.3 volt. So for V in greater than, for V in less than minus 0.3 volt, you are having minus 1 volt. You are having minus 1 volt. This is our minus 1 volt. This is minus 1 volt. Okay. Now tell me one thing. Now for V in greater than minus 0.3 volt, your V naught is V in minus 0.7. So will the graph will go something like this? Will it cross the origin? Tell me, will it cross the origin? No, it will not cross the origin. The slope is positive, the slope is 1, but it will not cross the origin, it will go something like this. Because at V in equals to 0 volt, you are having minus 7 volt. When your V in is equals to 0 volt, when V in is equals to 0 volt, you are having minus 0.7 volt here. Are you getting my point? So that's why it will not go from the origin, it will go like this. Understood? And when V in is equals to 0.7 volt, at that time you are having V naught equals to 0. V in equals to 0, that means V naught is equals to minus 0.7. V in equals to plus 0.7, that means V naught is equals to 0. Well and good? Understood? So that's how we will make the graph. So what is the value of this graph? V naught equals to V in minus 0.7. Okay. So now positive series clipper circuit with positive bias. And then we will study positive series clipper circuit with negative bias. Then again one more question. So this way we are studying. So try doing it on your own again and then just see the solution. Okay. So let's do this. So we are applying the open circuit test. This point is VB and this point is V in. So first thing, when V in is greater than VB, that means N side is having more potential and P side is having less potential. That means diode will be off. And if diode is off, what will happen? Your V naught will be equals to VB only, right? Diode is off, that means no current through the resistor, so VB will come. So V naught is equals to VB only. Okay. And second, when V in is less than VB, when V in is less than VB, that means your diode will be on, because this potential is N side is having lower potential and P side is having higher potential, and diode will be on. If diode is on, that means your V naught will simply be, if diode is on, V naught will simply be equals to V in. Okay. Let's draw the transfer characteristics. If we draw the transfer characteristics, what is the point of transition? The point of transition is VB. So for V in less than VB, your V naught is equals to V in. So for V in less than VB, your V naught is equals to V in. Wait a minute, I need to change the color. V in less than VB, V naught is equals to V in. That means at V in equals to 0, your V naught will be equals to 0. That means it will pass through the origin. Then for V in greater than VB, your V naught is equals to VB. So that's how the graph will look like. Understood? Okay. So when V in is greater than VB, your output will be equals to VB only. This will be your output. And here this is V naught is equals to V in. So what is our transition point? That is VB. Now that we can draw on this graph. Transition point is VB. Okay. So for every value less than VB, for every value less than VB, every value less than VB, V naught is equals to V in, otherwise it is VB. So let's assume this point is VB. If this point is VB, then for every value greater than VB, so for all these values, what will happen? For all these values, your V naught will go to VB only, right? And V naught will go to VB only. sorry. From here it will start. From here it will start for every value greater than Vp. For every value greater than Vp. And for less than that, it will be equals to V in only. Less than that. Okay. Yeah. So here your V naught is equals to V in. This point is Vp. Did I make the graph correctly? For V in less than Vp, your V naught is equals to V in, and for V in greater than Vp, your V naught is equals to Vp. Okay. Let's move on to the next circuit, that is positive clipper circuit with a negative bias. So there is a negative bias now. Okay. So let's do the analysis. Let's apply open circuit test. Now this point will be minus. This point is our V naught actually, but this point is V in. But since this resistor is there and this negative bias is there, for open circuit test, this point will be minus Vb. So first we will see when V in is greater than minus Vb. If V in is greater than minus Vb, that means N side is having more potential, diode will be off. And if diode is off, that means no current will be flowing through the resistor, so V in naught will simply be equals to minus Vb. And second one, when V in is less than minus Vb, that means P side is N side is having lower potential and P side is having more potential, diode will be on, and your V naught will equals to be, if diode is on, then simply V naught will equals to be V in. Okay, you can draw the transfer characteristics. V naught, V in. V in is minus Vb. Okay, so for lesser than that, V naught is equals to V in. V naught is equals to V in. And after that, V naught equals, wait a minute. So for V in less than minus Vb, V naught is equals to V in. And after that, it is minus Vb only. So after that, it is minus Vb only. So before that, it is like that. Okay, with slope being positive. So V naught is equals to V in. And eventually, it is going to be minus Vb only. Okay, so at V in equals to minus Vb, what is the output voltage you expect? At V in equals to minus Vb. At V in equals to minus Vb, your output will be minus Vb only. So you can add the equal sign anywhere. You can add the equal sign here as well or here as well. Okay, so anywhere you can add. So V at V in equals to minus Vb, your output will be equals to minus Vb only. Okay, so that's how the graph will go. Well and good. So what is our transition point? That is minus Vb. So we can draw it. That is minus Vb. So when V in is greater than minus Vb, that means at that time your output will be minus Vb only. When V in is greater than minus Vb, that means for all these points. Okay, so for all these points, your output will be equals to minus Vb. All these points output will be equals to minus Vb. Then it will follow the input. Then again it will be minus Vb. Then again it will follow the input. then again it will be minus VB. Okay, so here your V naught is equals to V in, otherwise it is minus VB. Well and good. Okay, let's move on to the next circuit. So you need to draw the transfer characteristics. Okay, now the diode is not ideal, so what you will do, you will take out the battery out of the diode. Okay, this is my V in. Now you will take the battery out of the diode and you will do the open circuit analysis. This point is V naught, this point is resistance R, this point is minus 1 volt. It is R, this point is 0. So tell me what will be the potential of this point. If this is 0, we are taking the battery out of it. This is 0, this is minus 1, this is minus 0.7. So this is minus 1.7. Okay, so first thing we will write, if V in is greater than minus 1.7 volt, that means N side is having more potential, that means diode will be off. And if diode is off, there will be no current through the resistor, V naught will simply be equals to minus 1 volt. Well and good. Second point, when V in is less than minus 1.7 volt, when V in is less than minus 1.7 volt, that means N side is having lesser potential and P side is having more potential, diode will be on. So what will be your V naught? V naught will be equals to, this diode will be on, so V in plus 0.7, right? V in plus 0.7. So V in plus 0.7. Okay. What is our transition point? What is our transition point? Transition point is minus 1.7. Transition point is minus 1.7 volt. So for greater than minus 1.7 volt, it is always equals to minus 1. For greater than minus 1.7 volt, it is always equals to minus 1. And for less than minus 1.7 volt, it is V naught equals to V in plus 0.7. That means slope will be positive. So the slope is positive. And also you can check slope is positive. Yeah. When V in is equals to minus 1.7. When V in is equals to minus 1.7, your V naught is equals to minus 1 volt. Okay. So you can check at this point at V in equals to minus 1, or you can check at V in equals to minus 2, what will be the value. At V in equals to minus 2, value will be minus 1.3. So it will be lesser than minus 1. So it will be somewhere here. So that's how you can check. Okay. So this is the transfer characteristics. That is V naught equals to V in plus 0.7. Well and good. So that's how we solve the problem. Again, one more question is there. You need to draw the transfer characteristics for this question. Okay, let's solve this question as well. Now we are very much comfortable with these kind of diode circuits, right? So we will be able to do the problems very quickly in the exam. And the best technique is, whenever there is cut-in voltage given, take the battery out of the diode. Otherwise, the problem becomes very complex. You need to think, okay, what value I should apply. Just take the battery out of the diode, problem will be very, very easy. It will be a cakewalk. So here also I will take the battery out of the diode. So always check the sign. While taking the battery out of the diode, just always check the sign. Otherwise, everything will be wrong, right? This is your V naught and this is your V in. Okay, this battery I am taking out of the diode, that is 0.7 volt. So tell me what will be the potential here? 1 minus 0.7, that means it will be minus 0.3 volt. Okay, so first thing we will take, when V in is greater than minus 0.3 volt, that means your diode will be off, right? Because N side is having more potential. 1 minus 0.7, that means, oh wait a minute, sorry. 1 minus 0.7, that means it will be plus 0.3, right? So when V in is greater than 0.3, the diode will be off. Okay, and when V in is less than 0.3, the diode will be on. Okay, and if diode is off, that means V naught is equals to 1 volt, because there will be no current through this resistor, so V naught is equals to 1 volt. Okay, and when diode is on at that time, if diode is on at that time, what will be your V naught? V naught will be equals to V in plus 0.7. V in plus 0.7. Right? Now you can draw the transfer characteristics as well. What is our transition point? That is 0.3 volt. This I am taking 0.3 volt. Okay, so for greater than 0.3 volt, it is always equals to 1. It is always equals to 1. It is always equals to 1. Now tell me, will this graph cut the origin? Will it go from the origin? No, because V naught is equals to V in plus 0.7. So at V in equals to 0, your output should be plus 0.7. So it should go something like this, right? At V in equals to 0, your output should be plus 0.7. And at V in equals to 0.3 volt, output should be 1 volt. That we are having. Okay, so it should go like this. So V naught is equals to V in plus 0.7. So always you need to check whether it will cut the origin or not. So it is not cutting the origin. Okay, V in plus 0.7. Well and good. Okay. Now in the next lecture, I think I should start. In the next lecture, we will study shunt clipper circuit. Okay, and then we will study two-level clipper circuit as well. So in the next lecture, we will be done with the clipper circuit. Okay, so it is simple diode circuit only. Nothing different is there. Simple diode circuit only, but just the naming is different. Okay, so I hope you enjoyed the lecture. If you enjoyed the lecture, consider liking the video and do share it with your friends. Okay, thank you.